Hi and welcome back. In this video, the first thing we are going to be looking at is string concatenation. So, string concatenation, and I'm pretty sure a lot of you can do string concatenation intuitively. Let's say I have a string 001 and I have the string 010. If I concatenate these two, I would get 001010. That's what concatenation would mean, just putting these together. But if you remember, we gave a more mathematical definition for what a string is, and it's a function from a set of numbers to the alphabet itself. So in that sense, we need a formal definition for what concatenation means, and that's what we're going to do. So let's say I have two strings over an alphabet. Let's say I have string x and I have string y. So these are my strings, and the concatenation of xy defined as just xy, or x and then y, like this. This is defined, this is equal to w if and only if. So when I write an if with two f's, it means it's if and only if the length of w is equal to the length of x plus the length of y, which is pretty obvious from the example that we took right here. So this is of length 3, this is of length 3, and this one is of length 6. So this is definitely one of the conditions that should be satisfied. The next thing that should be true is that w of j should be equal to x of j for j equals 1, 2 and so on up to length of x. And the last thing that needs to be satisfied is that w of length of x plus j should be equal to y of j for j again going from 1, 2 and so on up to length of y. And let's see what this means. So w is this string right here, x is this. Let me change color right here. So this is x, this is y, and let's see what w of 1 is. So my j is 1 now. So I'm looking at this condition right here. So w of j is w of 1, which is 0, and x of j is 0 right here as well. So this is satisfied, this is equal to this. Then w when j is 2, this is a 0, w of j is a 0, and xj is 0 as well. And for j equals 3, wj is 1 and xj is 1 as well. Now let's go to the second condition, this one right here. In this case, for j equals 1, what we get here is length of x, which is 3 plus 1 equals 4. So w4 is this 0 right here. So this one is a 0 and this one is a 0 as well, which is yj. And you can do this for this 1 as well and the last 0. So I hope this formal definition of string concatenation makes sense. And one thing to keep in mind is that string concatenation is it won't be commutative, of course, because x concatenated with y will not be the same as y concatenated with x. It is, however, associative. So for three strings, whether if you want to do x concatenated with y concatenated with z, the order in which you do this won't matter. And I hope this intuitively makes a lot of sense. So the next thing I want to look at is some operations on languages themselves. So what if I have two languages if I have two languages A and B, so these are languages, and here the first operation I'm going to define is A plus B, or we could just call it A union B. and this is basically just some A where A belongs to A, and union some B such that B belongs to the language B. And what this means is, let's say I have the language A is 0 comma 1 and the language B is 2 comma 3. Then my language A plus B would be something like 0 comma 1 comma 2 comma 3. So this is what my language would become. So this one is my A plus B or A union B. So it's exactly the same as set union. So that's the first operation. The second one is again A and B are languages, and the second one is AB, which is basically we could call this a concatenation for languages. What this means is we take an A where we take AB such that A belongs to the language A and B belongs to small b belongs to the language B. And let's take this through an example. It would make much more sense. So if I have, let's say, A which is 0 comma 1 again, and B which is 2 comma 3. So my language AB now becomes 0 2. So I take this A and this A, and then this A and this B. Then I take this A and this B, so it gives me 0 3, and then it will also give me 1 2 and 1 3. That's what this means. Basically, it's just concatenating every symbol from A with every symbol from B. That's how I get this language right here denoted by AB. So that's the second operation that I wanted to define. The third and last operation that I want to talk about is something called iteration, and is denoted by A star, where A is my language, and this is also known as the Kleene closure, Kleene iteration, or Kleene star. And this is just A concatenated with itself I times where I is greater than or equal to 0. And if I had to give a more formal definition for this, I would say that it is the set of all W's where W is equal to A1 concatenated with A2 and so on up to AK. For any K greater than or equal to 0, and also A1, A2 and so on up to AK all belong to A, all belong to the language A. So let's take an example right here. Let's say I have the binary language 0 comma 1, then some string 0 1 1 is actually A star. It falls into this category, and that's because it can be written as 0 concatenated with 1 concatenated with 1, and each of these symbols individually belong to this language right here. So that's what it means. It is just concatenation of any number of symbols from the language. And one thing I want to take note I want you to take note of here is that this k can be 0 as well. So I said greater than or equal to 0, which means that this A star also contains epsilon, which is the empty string. So it contains epsilon, which is the empty string, and this is true no matter what my A is. And at this point, I also want you to be careful about epsilon, which is the empty string, and phi, which we know is the empty set. So these are two different things, and I like you to be careful about these. And if let's say at some point I take phi star, that would also be a set containing epsilon, which is the empty string. And one property of the empty string itself that we need to keep in mind is that the length of an empty string is equal to 0. So that's one of the properties that we need to keep in mind. And that's it for this video. In the next one, we'll be looking at regular languages and regular expressions. So I'll see you there.